In this video, we will compare the table of values, the equation, and the graphs of linear, quadratic, and exponential functions. The first one we will look at is a linear function. Here I have y equals 2x plus 1. The exponent on x is 1, which is what makes this a linear function. I have a table of values here. My x values, I went from -3 to 3. This is my equation that I use to find my y values. And then these are the y values. So I've already done this because this should be very familiar to you. And then I'm just going to plot the points on the graph to the side. So the first point I will plot is -3, -5. And you will see that over here, -3, -5. And then I plotted all the other points. Then you would join the points in a line and label the equation. And that is our linear function. Something that you likely have seen before is calculating the first difference. So the first difference just means how do the y values change. So if we look from -5 to -3, we go up by 2. From -3 to -1, we again go up by 2. -1 to +1, we go up by 2. 1 to 3, we go up by 2. 3 to 5, we go up by 2. And 5 to 7, we go up by 2. So when you have a linear function, the first differences should always be the same. And you may have noticed that our slope of this function is 2 and the first differences are 2. If the slope was 3, the first differences would be 3. If the slope was -1, the first differences would be -1, and then our line would be sloping downwards. So next we will look at the quadratic function. I have the equation y equals x squared minus 3. The exponent on x is 2, which helps us recognize that this is a quadratic function. Again, I've chosen x values from -3 to 3. Here's my equation where I substituted in the x values and then I found the corresponding y values. I have already plotted these values on the graph, and now I'm just going to join them as a parabola and label the equation. So again, we're going to calculate the first differences. So here we're going from a y value of 6 to a y value of 1, so we are subtracting 5. And then we're going from 1 to -2, so we're subtracting 3. And then we're going from -2 to -3, so we are subtracting 1. Then we're going from -3 to -2, so we're now increasing by 1. Then -2 to +1, we're increasing by 3. And then 1 to 6, we are increasing by 5. So you will notice that the first differences are not the same, and we knew this was going to be true because this was not a linear function. So next what I'm going to do is find the second differences. So that's the differences of the differences. So now I'm going to compare how the first differences change. So -5 to -3, I'm increasing by 2. -3 to -1, again, I'm increasing by 2. -1 to +1, I'm increasing by 2. +1 to +3, I'm increasing by 2. And 3 to 5, I'm increasing by 2. So now we see that in a quadratic function, the second differences are the same. And this will always be true of a quadratic function. The final function we are going to look at is the exponential function. So I have y equals 2 to the exponent x plus 2. So now the exponent is our unknown. So x is the exponent, and that can change depending on what x is. So I have set up the table of values. This time I just went from -1 to +3. If not, we get into some pretty ugly fractions. I've substituted in the x values for each row, but I'm going to calculate the y in a bit more detail than I did above. So 2 to the -1 is 1 over 2, plus, which is a half, plus 2, so that's 2.5. 2 to the 0 is 1. Then I add 2 to get 3. 2 to the 1 is 2. Add 2 to get 4. 2 squared is 4. Add 2 to get 6. 2 cubed is 8. Add 2 to get 10. So now I will plot these points on the grid. When x is -1, the y value is 2.5. When x is 0, the y value is 3. When x is 1, the y value is 4. When x is 2, the y value is 6. And when x is 3, the y value is 10. And then we join those points into the exponential curve. We will go into a lot more detail about how to graph exponentials, both increasing and decreasing, in a future lesson. Now, exponential functions actually have a common ratio. To find that common ratio, we're first going to calculate the first difference, which is how the y values are changing. So from 2.5 to 3, I'm increasing by 0.5. From 3 to 4, I'm increasing by 1. From 4 to 6, I'm increasing by 2. And from 6 to 10, I'm increasing by 4. So we actually don't need to calculate the second difference for an exponential function. But what we are going to do is look at how the first differences are changing. If you notice, 1/2 to 1, you were actually multiplying by 2. 1 to 2, you were also multiplying by 2. We should have another line here. And from 2 to 4, you were also multiplying by 2. So we have a common ratio of 2. And if you look, that is the base of our exponential function, this 2 right here. You actually don't always have to calculate the first difference. Sometimes you can actually see the ratio right from the y values. It all depends on if there's a vertical shift up or down. And in this case, there is. And because of that, the y values are not clear about what the ratio is. So it is good practice to always find the first differences. And then once you have the first differences, you can find the common ratio. So some questions won't give you the equation. So I could just give you a table of values. You would find the first differences. If they're the same, you'd say it's linear. If not, you would then check out to see if the second differences are the same. If they are, then it's quadratic. And then if it's not linear or quadratic, you would then take the first differences and find the common ratio. And if the common ratio is the same, then it is exponential. For the 11U course, you only need to recognize if something is linear, quadratic, or exponential.